Hi, this is a short video, hopefully short, demonstrating the analog signal generator that I built over the weekend. I lost my industrial loop calibrator or misplaced it, and I thought I'd have a go at building my own with what I've got in my workshop. So I'll go through the drawing. So what I've done is used an Arduino Nano, and I'm using pins 3 and 5 to generate a PWM signal, which I then smooth out with a 1k ohm resistor and a 4.7 microfarad capacitor. That then gives a fairly smooth 0 to 5 volt, which I then put into a dual op amp, which is an LM358. I then use that to have a gain of 2, so that will then have an output of 0 to 10 volts. With an input coming from a 12 volt supply. I use both of these signals, but I use them differently. So the first output I'm just using as voltage, so I get a 0 to 10 volt signal out from there. And then the second one I pass through a 500 ohm trim pot, which I then get the 4 to 20 milliamp signal. And on that sort of pin 5, so on the PWM from that, I don't take the voltage all the way down to 0. So I bring it so it effectively gives me between 2 and 1 and 5 volts, which equates to 2 and 10 volts. I'll just move my laptop a bit. And then the input to this is a potentiometer that then varies the width of the PWM. I will demonstrate the analog signal generator here. So that's it on. I'll turn it around. So we get 4 to 20 milliamp or 0 to 10 volt output. Toggle switch to turn it on and off. Potentiometer to change the signal. And I just made out a proto board over the weekend. So there's the Arduino Nano. That's the LM358. That's the trim pot for setting up the 4 to 20 milliamp signal. I'll put the lid back on. So I've got it connected up at the moment to a PLC. It's a little Siemens logo PLC to demonstrate the program, and I'm using analog input 1, which goes into input 7. So I think we get 2 analog inputs on this logo. I might be wrong. And these are fantastic little PLCs. I've pretty much standardized them, mainly because I find the software easy to use. I use, they can replace trip amps, relays, that sort of thing. These 24 volt ones are good because you've got the analog input signals, so that makes them really useful. So, you know, one PLC can replace timers, relays, trip amps, all sorts of things. Right, so this is a program I've got running at the moment, which is to demonstrate the 0 to 10 volt. So on the program you use an analog threshold as a special function, and if you look there, I've got it set to 0 to 10 volt. And I've just used this little sort of traffic light in a junction box to demonstrate the program, and then you turn them on and off using the potentiometer. So that's just simulating outputs really. And then I've written another one using 4 to 20 milliamps. So if you look at the special function registers here, they are then working on 4 to 20 milliamps. I'll cancel that. Really easy to upload it to the PLC once it's set up. It's all done through an IP address. So that's now connecting, stops the PLC, and then it's running. So that's running the 4 to 20. I need to swap the signals over. So now I change it to the 4 to 20 milliamp signal. So I've got a different program. not the best program. I need to set the thresholds up a bit, but that then is just a different program to demonstrate that I've got 4 to 20 milliamps and not 0 to 10 volts. Pretty straightforward really. I also got another project which I'm going to try, and I'm going to use this ultrasonic with an Arduino, and that's where the sort of combination of the PLC and the op amp circuit really comes in handy, because obviously we would only get a 0 to 5 volt signal out of the Arduino, so I can then adjust that signal. So I'm going to disconnect it and connect it into this lever lock terminal block. So now we're using the ultrasonic. So if you look, I'm just moving my hand, and it's effectively telling me how far my hand is from the ultrasonic, but the industrial PLC is controlling that. So you can see my hand moving back and forward. So that then, it means using this system I can now trial different sensors, so on industrial controls, and just put them through this op amp. So it gives me more options. I have got the oscilloscope set up, so I can just connect it onto pin 3. I'll turn it down a bit. You can see the PWM signal. I'll turn it down again. And that's gone narrower. And that will obviously change the voltage. In fact, I could do that as well if I connect it onto the 0 to 10 volt. There's a bit of interference. You can see the signal going up and down. I think that's because it's such a long ground cable. I'm picking up a bit of interference from the cables. Just one last demonstration. So I'll get my multimeter, that's set to milliamps. So I will disconnect this. And then so if I bring it down, it's about 4 milliamps and about 20 milliamps. So that gives me quite a good 4 to 20 milliamp signal. So it's now really fully tested. I've got it working in real time with the PLC. It gives me an accurate reading on the multimeter, and then obviously I've tried the system using the Arduino to control to put a signal into the PLC, which is it's actually really useful. So I would like to say I'll do a write-up, and if anyone else wants to have a go, I'll put a link below in the comments. Thanks for watching.